Okay, so this is another type of calculation. It involves titrations and how to read the burette and whatnot. So what is this? A titration. Excuse the sound, man. Come on, the location. I'm sorry, location. So a titration king, what? A way, or a method, a way or a method to determine the concentration of an unknown substance. Yeah, so that's a titration. So in most cases, you have what one a standard solution, right? The standard solution king, solution in which what the concentration is what is known, right? So aggregate substance A, let's say it's the acid, right? And then the other one, it will be what? The one with the unknown what? Concentration. Yeah, it could be either one, So I in this case king base, right? So I titration out to A to know information about what? B. So we might know the information about the acid, and then we're then required to know the information about what? The base. So that's how a titration works. How it works now again is that we have to put in a procedure. So this is the procedure for a titration. Burette, right? Every time ke gopola burette ke no gopola lerette. So this is a burette, and then this is a conical flask or an Erlenmeyer flask. Conical flask, yes. And then so what happens is that we're going to put here carburet. We put the substance that we know the concentration of. So in here we know the what? We know the concentration. We know the concentration. So we put the substance in which we know the concentration in the burette. In the conical flask, we add the unknown substance. Concentration on unknown concentration. We put it in the conical flask, and then we put it in the conical flask, and then we add what is known as what? As an indicator. I'm sure you know these things, right? And then what is the procedure? The procedure is that as I add substance, eventually this thing, the acid plus the base will form a neutralized solution, right? The acid will neutralize the base, right? That's what acid neutralize a base. The two products that are made a salt substance plus what? Plus water. So that's going to happen. How will we know acid neutralizing base? Because there's going to be what? A color change. There's going to be a color change. The color change will tell us, or no man, there's what? There's neutralization. The acid has neutralized the base. In simple terms, we could say acid the base come. So with this type of calculations, the procedures that you do at or CA, VA all over what? A, CB, and then VB all over what? B. So that's the main equation that they use for the titration. It's this one. And then what else? Yes, the premise here, or I would say a memo once again. Go read this thing. You must learn how to read this burette. So this burette, what offer? They will get burette. But okay, volume if it's a concentration, concentration and 0.2 mole per cubic decimeters, right? And remember, the one in here it's unknown. The one in here it's unknown. So it's unknown concentration on a reading rate. But what we will know in here, volume. So let's say teacher 15 cubic centimeters. Yeah. So here, how will you know the volume for this one? How will you know the volume? You will know the volume by reading the burette. You must read what? Read of the burette. So that is the skill that you must have in order to tackle these questions. You will have this. You will have this, right? And then this you must read of what? The burette. And then you also have this one really right? And then also this one you will have, this one you will have. So here you will have two things that you must find. You must find the volume added. This volume added, obviously it's coming from what? It's coming from the burette, right? So how will you know the volume added? You must have the skill of reading a burette, right? So how will you know this? You must know how to read of a burette, and then I'm gonna do that now shortly. And then after that you can now solve for what? Solve for CB, or the unknown concentration. I'm not saying all the time concentration are basic to unknown. This one I'm going to for example. So that's that. I'm gonna do a question now with you. Oh, the other thing that they ask in this type of questions, nature titration. What do which are okay? Yeah, okay. But yeah, that is the thing. So let me stop now and find a question. Okay, I found an activity for this. So let's read it off here. A burette is used to measure the amount of solution dispensed. The burette readings are done at the start, this is very important, and finish of the titration, and the difference between the volume readings is the amount of solution that has been what? Added to the flask. The volume is read at the bottom of the liquid meniscus. When they're talking about the meniscus, you see, like what I want more beretiki, like at the bottom of that thing is called the meniscus. So it's like this. Okay, and then kako fast. Look at the line or the tangent line into a meniscus. So for this one, can you see the meniscus is here? The meniscus is here. So when you read the burette, you read over the meniscus. That is the bottom part of the tangent line. So when I'm going to read this, I'm going to say, oh, value more somewhere. So the meniscus for this one is here as well. This one is here as well. This one is going to move fast. So now let's focus on trial one. Let me show you how we read this. So this is the initial point. Rather, let me say V initial volume, and then to change till volume left tamoki. Question the amount of volume that is added, they said is what? It's the difference, which is V final or minus V initial, and then you will get what? The volume added. Right. So now let's see. Now how do you read this burette? So moki one, it's one. The difference. Now. How you read a burette is that moki one, right? Moki over 1.1, 1.2, 1.3, 1.4, 1.5. Do you see that? 1.6, 1.7, 1.8, 1.9, and 2. Do you see that? So difference in over like 0.1. So if moki 1, right? 1.1. So V initial, the volume reading at start, it's what? 1.1. 0 what cubic centimeters, right? So what is the final one? Arval. So 20, 20.1, 20.2, 20.3, 20.4, 20.5. Now if we want like more igare imagareng nyana, so like imagareng ga 20.5 li 20.6, you just take the average of the two. So what is going to be that value? 20. So v final over 20.5 plus 20.6 divide by 2. Why divide by 2? Because I want a meniscus, so like so we can say it's the value there. So 20.5 plus 20.6 divided by 2, I get or guy 20.55. so the final volume is what? 20.55. Uchichi volume maker in trial 1, it's going to be what? V final minus what? V initial. The bigger value minus what? The smaller value. So in this case it's going to be 20.55 minus what? Minus 1.1. and then rabona o moto by 19.45 what cubic centimeters. So yeah, that's how that's how a burette reading is read, you know. Let's go to trial 2. We're testing do we know this shit now? So let's see. So this will be what? V initial, which means even V final. So go 1, 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7. Can you see the meniscus imora? So meniscus over V initial. V initial leo e gara 1.7 lenge 1.8. So it's in gara recha vila so that we know what is the estimate there. Plus 1.8 divided by 2. 3.5 divided by 2. Give 1.75 cubic centimeters. So 1.75 cubic centimeters there. Okay, V final, let's see V final. 21, 21.1, 20. So can you see it's not okay? I think it 21.2. yeah, it falls on that. So get 21.20 cubic centimeters. The question get the volume that is added, it's V final minus what? V initial. So it's gonna be what? It's gonna be 21.2 minus 1.75, which is like what? 19. That's nice. 19.45 what? Cubic centimeters. So that's how you read a burette. Now I'm gonna send this video, you're gonna watch it, and then before the next question, I just want you to understand me here, because that's not my question or some question.